Hey there, Leo here, and I am smiling, and I hope you are too. You might notice there is a new background behind me. That is because I've moved, and the house, the reason why there was no content for a while is the house we were moving from ended up getting flooded, and it just created a nightmare. So, anyways, long story short, I'm back to create some new content. So, speaking of content, what are we going to learn today? Well, today you're going to learn how to test any indicator and see if it has predictive power. We're going to use a simple linear regression machine learning to figure out whether or not, more specifically, anchored VWAP and the anchored SMA and SMAs actually have some predictive power. I know that anchored VWAP is thought of very fondly among a lot of traders, and I'm not here to knock it. I'm just going to show you my results, and without digging in too much in detail, they weren't that great, right? I'm not going to be using the anchored VWAP, but again, you can check out the rest of this video, or if you're not interested in the code, I have another channel where my next video where I'm just going to discuss these results and how it relates to trading. So without dragging this on any further, hopefully you enjoy this one. Let me know how it goes. I'm just resetting up all the equipment and all of that stuff. So I'd love to hear any constructive criticism or how I could make these videos better. All right, thanks. So the first thing that we're going to want to do is get our required imports. And in this instance, I'm going to use my own database that I've populated with my own price data. I teach you how to do that on this channel. If you don't have your own database, feel free to get the data freely from Y Finance, which I also show you how to do. So I'll link the Y Finance tutorial video in the description below. That way you can follow along with free data if you don't have your own. So we'll get the required imports. Get required imports. Now I'm going to import sys because I need to add my local path so I can access my data. Import sys path append home Leo Smiggle development alpha I that. So this will allow me to access some of my data. That's essentially what I'm doing. I'll point it out exactly when I'm doing it too. So we're going to import the standard. We'll import pandas, numpy, stats models for the linear regression and p-values, and pyplot for plotting. So import pandas as pd, import numpy as np, import stats models as sm, import matplotlib pyplot as plt, and then we'll do a start date. Get a lot of it, so we'll do 2003-0101, and end date equals 2022-12-31. Perfect. So that will give us our initial imports. Now the next thing we need to do is get our S&P list. Now this is going to get us the S&P 500 list quickly and easily. Scrape the S&P 500 list. Now keep in mind, the reason why we're doing this is that we want a quick answer, right? We're not looking for perfection here because there are some issues with just scraping the S&P 500 list like this with, various biases with look-ahead bias and survivorship bias and all that other stuff. But for right now, we don't really care about that. We're just trying to identify, does this even make sense? So we'll just scrape the S&P 500 list, and it should give us the answer that we're looking for. And if we want to pursue it further, we can have a more vigorous backtest. So anyways, we'll import requests. So that way we can make a request to Wikipedia, and then we'll use beautiful soup to go ahead and manipulate that request. So beautiful soup. Now we'll create a function to scrape the S&P 500, scrape SP 500 list. And now what we want to do is pass in the URL. I have this already punched in. And now what we want to do is we want to take the response from request.getURL. So we make that request using this request module, and then we pass in the URL and we get a response. Pretty simple, right? Now we use soup to parse it. So soup equals beautiful soup response text. We'll do HTML parser. And now what we want to do is we want to grab the table. So table equals soup, find table, and pass it the class. So that way, it knows exactly what we're trying to target. So wiki table sortable. And the rows equal table, find all, tr for table row. Now, symbols. Now that we have the data, the rows, now we just create a list of the symbols. An empty list for row and rows, right? We'll skip the first row because that's a header row. Symbol equal row, find all, the TD or a table definition. First one, text strip. So symbols, append symbol. Then turn symbols. SP500 list equals sorted, sort them, scrape SP500 list, and then print SP500 list, and we'll just print the first 5. Hopefully I didn't make any typos, and of course I did. All right, so where did I mess up? Couldn't. The tree builder with the features you requested, HTML parser. Parser. Well, makes sense. PARSER. There we go. So now we see that we have, the S&P 500 tickers. So fantastic. Now the next step is to get the prices. Getting the price list is pretty easy. Again, you can use YFinance, or if you've already built your own database, get daily prices. Use the function. So from, these are, this is my data, right? From SRC, which you notice is, of course, for my specific Alpha AI project where I imported it up here. If you're wondering where that is, you don't have that unless you've named it the same. But the point is, either import using YFinance or your own stuff here. So models, API, import, get daily prices, df equal get daily prices, SP500 list, start date equals start date, end date, not the df. That should give me the prices. And this can take some time because, again, we've got however many tickers from what do we say, 2003. Now that we have our data, let's go ahead and create our VWAP and anchor point. Date, VWAP, and anchor. If you're not sure what VWAP is, I have an article both on AVWAP and VWAP that teaches you how to calculate and all of the details about that. I'm not going to cover that here because we've got 10 steps to go through, and I don't want to spend the time discussing what VWAP is. If you're here, the whole point is to learn how to code this stuff. But if you need the additional assistance, just check out the website. All right, so now first we're going to create our 2 periods, and then we need a anchor threshold. What I mean by that is we're not going to decide, hey, this news should be anchored or this news shouldn't. All we're going to do is look for a volume spike that is 3 times larger than the 20-day moving average, and we'll anchor to that point. So VWAP period equals 20, anchor period equals 20, anchor volume multiplier equals 3. So 3x anchor period average volume. Now what we want to do is we want to calculate the typical price. Some VWAP calculations only use close price, but the proper pedantic or maybe academic way to do it, or where the most authoritative sites say the typical price, which is simply an average of the low, high, and close. Let's calculate that now. df typical price equals df low plus df high plus df close, and we just divide by 3. And now we need to calculate the volume for that price period, so weighted. So df typical price times volume equals df typical price times df volume, right? So this price will now be weighted by that volume. So assuming that all worked, which it did, now we have all of the requisite stuff to be able to create our VWAP calculation. So VWAP equals, now we're going to group by, not root by, but group by ticker. Now, why are we doing that? Well, what we don't want to accidentally do is have Apple's volume on some other ticker's price, right? So we want to make sure that VWAP is only calculated through each one of these bounds because we're, rolling, doing like rolling average, and we don't want to actually roll our average to the wrong ticker. So we'll do df dot group by, right? Makes sense because we're grouping by the ticker. Then we'll take this EPX volume, rolling, and then VWAP period. So what are we doing there? We're grouping by the ticker and taking the volume, which will be volume, EPX volume, and then we're adding it, the last 20 periods or rows and summing it. Okay, so that's the first part. Then what we want to do is we want to divide that by that price, right? Now what we want to do is, now that we have that typical price times volume, we want to divide by the total volume to get that weighted price. We'll do df group by ticker volume rolling same period, that period, sum that up. Now what we'll do is we'll reset the index level 0 and drop equal true. So that's just so we can add this. And let's go ahead and F. Oh, of course, I get something up. Oh, fix. Data frame object has no attribute group by. Look at this, getting out the initial YouTube jitters. There we go. So now we can see that we have this VWAP. And this makes sense to have these nans here because, right, we need those 20 values to be able to calculate that because it's a rolling 20 period. I'll go ahead and delete this. And now that we have our VWAP calculated, what we'll do is we'll calculate the simple moving average so we can compare them, right? So df SMA equals df group by ticker. Again, since we're using that rolling, we want to make sure that we don't roll across ticker boundaries. So rolling VWAP period mean, right? So all we're doing for simple moving average is we take, the sum of the prices, and then we just divide by, however many rows there are, or take the mean. Then I'm going to reset the index again, level 0, drop. Cool. If now I have, okay, and now I do. So perfect. So that calculated for both the SMA. Now we got a few more things to do. We want to calculate the fields where there's that anchor spike, and then we want to check them. So do that now. So anchor volume spike equals df group by ticker volume, and we'll do rolling VWAP period. Oh, actually, I should do anchor period, even though they're the same. Anchor period mean times anchor volume multiplier. That index level equals 0, drop equals true. And that's just so we can set, right, that, get that value. All right, so let's see if that's the case. what we do is we group by the ticker on volume. We roll that over 20 and take the average. So we got the average 20-day volume and times the multiplier. So what this will do is it'll take, this is the anchor volume requirement, right? So 3 times the average rolling volume. Now all we need to do is create a true or false field for if there is an anchor spike. So anchor df volume is greater than anchor volume spike. Makes sense? Then run that, no problems, and then let's test it. What we'll do is we'll go to df anchor equals true. And then what I'll do is I'll just call that so we don't have none of them. So then we can check to see on these dates whether or not there was indeed a volume spike. Now that we have the data, we can analyze the VWAP versus SMA returns or simple moving average returns. And then we'll do the anchored VWAP, right? Because it's a little bit a step above from the complexity level. So analyze VWAP versus SMA returns. And sorry about the sound. I did notice it was chopping. Hopefully this will be a little bit better. But anyways, what we're going to do here, I'm just going to copy and paste some code and explain it because I think that would be easier. So what we're going to do first, because we have this multi-index, is we're going to reset the index, right? So that means this multi-index, ticker and date, they will now be columns. This then allows us to sort the data frame, which it shouldn't really unsort it, but just to be safe, I put that in there. And then once we have it sorted, we're going to calculate the daily return. And that's pretty easy to do. All we do is we group by again because we want to make sure that the percentage change is limited by, that ticker bounds. So we're not calculating like Apple's price change with Tesla's or whatever, right? So we create this daily return by doing the percent change, grouping by the ticker. And then how we're going to analyze whether or not these indicators, meaning the simple moving average or VWAP, has any predictive power, is we're going to calculate the distance away from price, right? So we can see here, we have the simple moving average. Let's just say it's 101 and the close is, 100 divided by 100. So then we can see, it's essentially 1% away, right? So the idea is the stronger or further away that the SMA or the VWAP is from price, it should potentially change that signal. That's why I did it that way. And then what we'll do, the same thing with VWAP. We take the VWAP price minus close and divide by close, just gets the percentage away from the close price, positive or negative. And then we calculate the return, right? So we can just cumulative sum. Now you might take issue with this, but it's a lot easier to sum some of these things and just look for predictive power than to have exponential returns and analyze that. So again, as I said before, we're prototyping here. We want simple, clean, and easy. We don't necessarily want precision, right? Because we want to say, yes, this meets our gate criteria. We're going to dig further into this. And then you start digging further into that. We'll drop the NaND values because there will be some NaND values because we're doing the percent change, right? So the first one, there is no percent change before it, right? So it'd be NaND. And then we set the index because, again, we reset that index earlier because there's a multi-index back in place and print it out. So I'll run this. And then we can see here we have our multi-index data frame. Once again, OHLCV, our typical price. Remember, that's just the average of the low, high, and close. Our typical price times volume. So that's our volume-weighted price. And then we get the VWAP by calculating the TPX versus the volume for that rolling period. We also have the SMA and the anchor. Why I can't move over there for whatever reason, but whatever, I'm recording. So anyways, so that gives us all of that information. And now we'll plot the returns. Let me go ahead and do a new section. I don't remember what, oh, 6. Plot returns. Go. And now what we're going to do is we're going to get a list of the tickers and simply plot all of the returns, but we're going to truncate the legend because we don't want a bajillion tickers just scrolling down the side of our page, right? So we already have NumPy, so we'll say tickers equal df index get level values. We're going to want to get the first index, which is the ticker, right? And then that would give us a bunch of tickers, right? So what we want to do is we want to get the unique values and then turn it into a list. And the reason why we get a bunch is because for every row we get ZTS, ZTS, ZTS. So we don't want that. We just want the unique values. So now that we have all the tickers, let's create a figure and an axis. So create figure and axis. I got to do a better job with comments. So that way, if you're looking at this in the future and trying to work through it, you'll have some more information. But anyways, big X equals, that's the figure, which is what the plot is on. And then the axes, we'll do plot, subplots, big size, 10, 6. We're not going to have any subplots. We're just going to have a bunch of larger plots. And then we'll loop through each ticker and plot the log daily return of sum. Maybe we'll do log, yeah. Probably doesn't even really matter, but anyways, we may do log. But for ticker and tickers, ticker data equals df clock ticker daily return of sum, right? So what we're doing here is we're just taking these daily returns for each ticker, right? So, and returning it into this ticker data. And then what we do is we want to plot for each ticker this data. So plot ticker data index, ticker data, label, ticker. And this should give us, right, add labels, legend. This should give us one plot with a bunch of tickers plotted on there, and hopefully we don't have many outliers, but we probably will, and that's why I did it with sum versus exponential returns, but we'll probably still run into the problem. But anyways, AX set X label. We'll just say this is the date. AX set Y label. This is cumulative daily return. Right, so this should actually be daily return. I'm not going to do the log. We did simple instead. And then handles, labels equal AX get legend handles labels. And then AX legend handles. Okay, now let's analyze the results. I'll paste this in here and go line by line. One thing that I think I messed up, let's scroll back up here. Yeah, we'll do stats models .api as SM. So need to fix that. Okay, so now what we do is I first create a blank data frame, right? This is going to hold the alpha of the VWAP and SMA signals. Alpha is also the intercept, but basically it just means the return above and beyond what would be expected. If you're curious about what that means, you can check out my website, Analyzing Alpha, to find out exactly what alpha really is. We've got a p-value and for both VWAP and SMA to determine whether or not the results are statistically significant. And now let's do some dropping. We drop any NaN fields from the data frame, and then also any ticker that has less than 50 data points, I just remove it. So that's pretty easy, right? So then the next thing that we're going to do is I'm going to go ahead and loop through every ticker, right? So for every ticker in tickers, we get the data. Remember, we have a multi-index. So instead of getting this whole thing, we'll just get the data for A and dropping the A, right? So it just gives us the data. So then what we do is we then define our independent and dependent variables, right, after the data cleaning. So this is that model preparation. So what we do is we have the dependent variable, or the thing that we're predicting, will be the daily return. Technically speaking, it's the next day daily return, right? That's why we see we start at 1 here. We wouldn't want to start at 0 because that doesn't really make any sense. We want to predict, take the VWAP and the SMA, use that data and again to predict the next day. And that's why I remove the last element from here and start, essentially remove the first element here, so they're equal length. But essentially what we're doing is we're just saying, all right, let's take VWAP and SMA distances and see if we can predict the next return to some degree. And then we fit the model, right? This just does all the calculations for us. We create the VWAP model, the SMA model. We get the results after fitting them. And then we simply plot it and plot the linear regression line and all of that other fun stuff. So if you're not sure how to do this linear regression thing, right? I've got a pretty in-depth tutorial that I thought was really good. It teaches you all about the different ways to do linear regression and take you through, but pretty cool project. Didn't get a lot of views. I think it's really good. If you're interested, check that out. That'll teach you all about this. And then after the titles, what we do is I create, for every row, we append the data, right, of the alphas, the stuff up here, right? So we create a new data frame called alpha DF with all that information, and I'll run it. And you'll see here that it starts printing out all of these graphs. Here's the VWAP equation and the SMA equation. And essentially, we're just looking for Y, which is the intercept or the alpha. And then this will going to take a little bit. But really what we're interested in here after all of this plotting is that we want to understand what is the average or mean alpha for all of this, right? So we have all of these tickers. And now what we want to see is, okay, does this really give us some results? So what I'll do now is I'll create a new row here and then run this. And what this is doing is we're taking essentially this mean row, right, and creating this. So we take all of the tickers, we just call this mean, and then the VWAP alpha, we take the mean of that, the SMA alpha. And the reason we're not doing sum or anything like that is that we want to kind of get rid of some of the outliers. I mean, we could have done median here, means fine. I mean, basically, again, remember, we're trying to get good, right? Good is good enough. It doesn't have to be perfect. So let's see, that'll take a minute to run. All right, so now we have the returns and we can see that here's the tickers. Now there's 500 of them. And then we have the VWAP alpha, SMA alpha, p-values, and SMA values. We see here that the VWAP has a little bit higher alpha than the SMA, but we also see that the p-values are above 0.5, which means that this is not statistically significant. So take that with what you will. All right, so now what we'll do, actually before I do that, I'm going to create another heading, analyze a VWAP versus a SMA results. And really what we're testing here is whether or not volume weighting makes sense, because a VWAP is essentially just a moving average that is anchored. And then I'll paste this in here and we'll cover it line by line. I felt like that was more effective. So the first thing we do is we get all of the tickers that have a volume spike. Okay. And then what we do is we make sure that the ticker has multiple anchors because of just how I used the logic down here. And there's other ways to do this, but again, remember, we're just trying to get quick results so that way we can prototype this, put this on our list of things to test further. We just create some containers for the results. And then for every ticker and the anchors index, we then get the data. We use the anchor indices, which I thought is pretty slick here. What we do is for start, end, and zip anchor indices. So what we're doing is we're taking this data and then we're looking at between these anchor spikes, right, or volume spikes, or 50 days if it ends within 50 days, right? So basically, if the data ends before 50 periods or there's another volume spike, that ends. But anyways, so then we just create the AVWAP and the ASMA using this new data. We've seen that before because we have to do it between the anchor volume spikes. And then essentially, just concatenating all the results together. And then here we have this, renaming it and finally merging all the data. So when I do this, this will give us a data frame of, that anchored VWAP and SMA data. So now what we want to do is let's just take a quick peek and see what does this actually look like on our chart, right? Did we actually do the VWAP correctly or the anchoring correctly? So we just create a plot, right? And then we loop through, each one of the tickers for the index essentially. And what we should see is a graph with the actual chart of a stock and then highlighted where the anchoring points occur. And since there's a lot of data, this will take some time. So I will see you as soon as it's done processing. And now we can see here that after this plot, we have the price for American Airlines in blue. And then we see the, the volume spike anchors, VWAP and SMA charted here in orange. So it does appear, that looks like that might be an earnings announcement. Well, they're probably mostly, if not all, earnings announcements, but it does appear that it works. And the maximum is 50 days unless another one occurs. So looks good to me from a visual inspection. So now let's go ahead and see if the anchored variants have any alpha. So the first thing we need to do is create the distances, right? We've already done this before. So I'll just copy and paste this over. I feel like this is an easier method, at least for me. Let me know if you like it being more interactive and watching all my typos or copying and pasting me just explaining stuff. So anyways, we create this AVWAP distance percentage, which is just how far away the AVWAP is from close in a percentage perspective, positive or negative. Same thing with ASMA. And then we go ahead and drop any NAs, and then we have our data frame with the AVWAP and anchored SMA distances, right? So now what we need to do is we need to go ahead and get tickers with AVWAP, right? So in the next section, we'll need all of these tickers because we need to loop through them just like we did, above in this code way up here, right? So I'll go ahead and run this. You can see here are our tickers, and now I'll create a new row here. And we're going to go ahead and paste this in. We can see we likely don't need this. We already have NumPy. We already have matplotlib because we've already plotted this stuff. So now what I'm going to do is just run this. Well, actually, before I run it, I'll explain it, right? We did touch on this pretty in depth, but this one, the second one, obviously we have two new columns. We have the SMA alpha and the SMA p-value, and we're doing the exact same thing. We're trying to predict this the dependent variable, and then from a bunch of independent variables, right? In this case, we have AVWAP, ASMA, and I've added just the simple moving average to see, does the anchoring matter at all, or should we just be using a 20-day SMA? So then we fit the models, plot it, we've seen all this before, draw straight lines, the best fit line. Then we create this mean row where we take all of the AVWAP alpha, ASMA alpha, SMA alpha, and the p-values, and we just take the mean of that. And then we'll run this, and you can see it'll start graphing quite a few things. And then this will take a minute or two. And then once that is done, we will go ahead and determine, does the anchoring actually help us generate alpha, which would be nice for, price earnings gaps or EPs, things like those types of setups. So with that done processing, let's go ahead and analyze the results. New section here. And for context purposes, let's get the prior result. So that was the alpha DF mean. If we recall, They were very similar, but they did not have significance because they're above that 0.05 threshold. So let's go ahead and see if the anchored variants are any better. So alpha DF2 mean, and here's the big reveal. So it looks like the AVWAP performs a little bit less than the anchored SMA value, and then the simple moving average performs the best, right? So it seems like the volume weighting or the anchoring actually hurts the indicator's potential profitability, and then we have no significance here. So what does this mean, right? So when you're looking at data, you have to figure out, okay, why is it the way it is, right? And try to hypothesize that. Well, my thought process in regards to anchoring is I don't think it's that great of an idea, because if you really think about price, right? Price is a discounting mechanism where you're essentially, the market is very good at getting the latest information. So a lot of times when you anchor on a lower price, let's just say in a post-earnings announcement drift scenario, you're actually using and heavily weighting volume that occurred earlier on in the period where price hasn't gone through that price discovery yet. So my initial thought process, when thinking through this before doing this, was that, anchoring is probably not that great of an idea because you're overweighting historical prices relative to newer prices, which are, in my opinion, and the market's opinion, you can't argue with it, right? I mean, it's incorporated as, that further information. So I think this makes logical sense. I'm not going to use anchoring in my strategies. How about you? What did you think? Did you like this video? And if you did, let me know between if you like me typing stuff out or if you like me, just explaining the code. And hopefully I'll see you in the next video. Thanks. Bye.